Okay, so now we know what data we want, what type of data we want, how to collect it, what kind of forms to use, when to get that information, what kind of methods to use. We know all that. We're good to go. So we go there and we collect data. Now we're gonna briefly talk about how do we know if this data is good for me or not. Okay, so there's some techniques that help you on that to check the quality of the data. Okay, and basically you want some characteristics of your data, right? You want it to have no difference between measure and true value. You want the value that you collect to be similar to the real value, so reduce the possibility of having any bias, right? Of having the data is change or different because let's say you only collect it in the morning, or only collect in the afternoon, or only collect one worker doing the job. So that these are some examples of bias that you're going to have in your data, right? So you want to be similar to the true value. You want that to be that doesn't matter who collect the data. It could be repeatable. What do you say? Repeatable and reproducible means that if you're using the same measure, you're repeating it. If different people are taking it, it can be reproduced, right? So different people taking, you're collecting the same way, or you're collecting multiple times, it will get you the same data. You also want them to have the possibility to produce the same results in the future. In the past means that if you're collecting the same data, you want it to receive it in the same way, and it have the ability to have meaningful differences. Basically, if you're collecting the data and you're getting always the same result, it means that you're not able to detect the difference between different parts of the population, right? So you want your data to be in a level of detail that you can differentiate things, because then you can test things that are different, right? And these are all two characteristics of data. It could be accurate or precise. So this is a data that is, for example, accurate but not precise all over the place. This is precise, not accurate, and this is what you want: accurate and precise at the same time. So the MSA, or Measurement System Analysis Roadmap, it's a way that we can use some methods to try to find some deficiencies and some problems with the data that you collect. Basically, you're doing the devil's advocate there and trying to break your data to see if it works. So there's a kind of a resolution rule. It's called the rules of 10. Then is the MSA drill down, which is kind of trying to understand with questions if there's something wrong. And there are some ways to test the repeatability and reproducibility of the data. We're not going to go into details. These are some methods that we're not going to go over. Okay. So the rule of tens, not rules of 10, rule of tens. It's basically trying to understand the resolution of your data. So you wanted to have enough difference between things that you're collecting, right? So let's say you're taking time of uh, uh, different process, right? And your process is it's very fast. Let's say it takes about 2 minutes, and you're not taking seconds, you're only taking minutes. So if you look at your data, say, oh, making a sandwich takes 2 minutes, 2 minutes, 2 minutes, 2 minutes, 3 minutes, 2 minutes, 2 minutes. Well, there's no difference between that, right? So probably you should be taking seconds instead of minutes. Then you're going to have, well, 2 minutes, 120 seconds. Then you may have 120 seconds, 119 seconds, 124 seconds, 110 seconds. They're all about 2 minutes. But if you only use 2 minutes, you're not going to be able to differentiate one observation of the other. If you take seconds, well, then you're going to get that difference, right? So that's what the rule of 10 is doing. Is it kind of testing if you have at least 10 different, let's say, pockets to put your data on, right? So think about a histogram, right? And we're gonna talk more about histograms. We're gonna do some histograms. I realized in previous classes that some people don't know what a histogram is, so we're going to work on that. A histogram, you have the bars, right? And you divide your data into bars, and then you put the frequency of each bar. So you have to have at least 10 bars so you can see a kind of distribution it is, right? If it's a normal distribution, if it's a uniform distribution, if it's a, this one everybody knows, the exponential distribution, or like this. So you wanna have at least 10 columns, and that's what the rule of 10 is, right? So let's take a look at this set. So I have data here, I have two decimals, so my resolution is 0.01 because it's two decimals. My minimum value is here, my maximum value is here from this data. My range is here, one minus the other one, and if I take that range and divide the resolution, is only going to give me 4. So I only have 4 different data points there on my data. So it's very difficult to see the kind of distribution that I'm going to have. In this case, I'm using only one decimal, right? But I have 14 different buckets there, right? So if I use 0.1 as my resolution, it's okay because my histogram will have 14 different data points. So it's more than 10. It is acceptable through the rule of tens.